So today's topic is about the general gas equation. What is general gas equation? The general gas equation state that PV is equals to nRT. And what condition we will use this equation? Basically, it is used to find unknown, like example, P stands for the pressure, V stands for volume, N is a number of the moles, R is a general gas constant, and T is a thermodynamic temperature or temperature. So P is the pressure. What is the SI unit of the pressure? The SI unit of pressure is Pascal or Newton per meter square. What is V? V is a volume. And what is the SI unit of volume? SI unit of the volume is meter cube. So that should be in meter cube. N, what is N? N is the moles. And the unit of the mole is moles ml, mol, sorry. And this T is the temperature. The SI unit of temperature is Kelvin. And R is known as a general gas constant. And the unit of this general gas constant is equals to 8. The value is 8.31. And the unit is joule per mole Kelvin. So this equation is known as a general gas equation. There is also another equation which you use, a formula which you use to calculate the moles or relating the moles with volume. So moles is equals to volume in dm cube the volume in decimeter cube divided by 24. But what is the difference? Like example here, finding the moles volume in dm cube divided by 24. This is also for the gas, moles of a gas, and we can also find moles of a gas by this equation. But this formula, moles equal volume in dm cube divided by 24, it is only valid if pressure is 1 atm. 1 atm is equivalent to 100,000 Pascal. So 1 atm is equals to 100,000 Pascal. And the temperature is equals to 25 degrees centigrade or 298 Kelvin. So basically what we call these conditions, we call this condition as standard condition. So at standard conditions, we will use the formula moles equal volume of a gas divided by volume of a gas in decimeter cube. divided by 24. But if, for example, if the conditions are not standard, like example, temperature is not 25 degrees centigrade and the pressure is not 1 atm, it is 2 atm or 3 atm. So in that case, you cannot use this mole equal volume in dm cube divided by 24. So in that case, what we use a general gas equation, in which PV is equals to nRT. But the important thing for this equation is a unit conversion. Like example, for pressure, the unit convergence is very important for this. So pressure will be in atm, but you cannot substitute pressure in atm, it should be in Pascal. So if the pressure is in atm, so what we will do, we have to convert into Pascal or Newton per meter. Pascal or Newton per meter square is the same thing. So if you want to convert the pressure which is in atmosphere into Pascal or Newton per meter square, so what we will do, we'll multiply by 100,000. And the temperature is in degree centigrade. We will convert to Fahrenheit. Sorry, Kelvin by mistake. Fahrenheit is also a unit of temperature, but not the SI unit. So what we will do, we'll add 273 because the temperature in Kelvin is equals to temperature in degree centigrade plus 273. And what about the volume? The volume will be in, like, it can be in dm cube, but the dm cube is not suitable. So what we have to convert, if it is in dm cube, we have to convert to meter cube, the SI unit. So for converting dm cube into meter cube, what we will do, we will divide by 1000. So that will be the conversion. So it is important to know these conversions, because the question will be very simple. The important thing when you're using this, it's the conversion, the unit conversion, and the value of the general gas constant, it is 8.31 joule per mole Kelvin. I'll give an example how you will use this equation to solve a question. Yeah, it is must that the temperature should be in Kelvin, because the SI unit of temperature is Kelvin. And you can see the general gas constant, the unit is joule per mole Kelvin. So if you substitute the temperature in degree centigrade in the formula, your answer will not be correct. Is it clear, this part, like what condition you will use this general gas equation? This is used to find the moles of a gas as well. So example, if the question was calculate moles of gas, and this is only valid to find the moles of a gas at 30 degrees centigrade and 2 atm, when the gas occupy 500 decimeter cube. So this is a question and you have to solve. So first thing, the equation, as we know, the equation for PV is equals to nRT. So P is the pressure, In the question, the pressure is given 2 atm, but I need pressure in Pascal. So if it is 2 atm, what I will do, because if I want to convert atm into the Pascal, I should multiply by 100,000. So 2 multiplied by 100,000, so this will be 200,000 Pascal. Then about the temperature or the volume, volume is given 500 dm cube, but the SI unit is not decimeter cube, SI unit is meter cube. So to convert decimeter cube into meter cube, what I will do, I will divide by 1000. So when I divide by 1000, that's equal to 0.5 meter cube. R is the constant, R is having a fixed value, which is 8.31 joule per mole Kelvin. And T is the temperature. So if T is the temperature is 30 degrees centigrade. So to convert into Kelvin, what we will do, we'll add 273. So 30 plus 273, what we'll get 303 Kelvin. So unit already we convert, so we can substitute the values. So it is 200,000 multiplied by volume, which is 0.5 moles. We are finding R is a general gas constant, which is 8.31 multiplied by temperature, which is 303. So if we need the moles, so this whole factor, which is multiplied, will go there in division. What's the final answer for the moles when you substitute these values in the formula? 200,000 multiplied by 0.5, so it will be 100,000, and 100,000 divided by the product of 8.31 into 303. What's the final answer? So you will get 39.15 mole. So that N is actually equal. So the only difference is this general gas equation is you can use this general gas equation in all the condition. Even at a standard condition, when I substitute the values, I will get the same answer. So that's why actually this is the previous, this formula moles equal volume in dm cube divided by 24 is actually a modification of the general gas equation. So if we use a standard condition, then we can use a simple equation. If the conditions are not standard, then we use a general gas equation. Is it clear? Now some questions related to this. So example, in the question, a rigid cylinder of volume 0.03 meter cube hold about 4 grams of air. The molar mass of air is about 29 grams. Calculate the pressure exerted by air when it is at a temperature of 34. So we'll solve the first part. Actually, it's this sheet is belonging to physics. So the question are more towards physics rather than chemistry, but we will only use a general gas equation to solve this. So we have the mass in gram of air and we have the molar mass of air. So first, because to use the general gas equation, we have PV is equals to nRT. P is the pressure which we are finding. V is the volume, and here the volume is already given in meter cube, so we don't have to convert. So that's equal to 0.03 meter cube. R is a general gas constant, which is 8.31 joule per mole Kelvin. T is the temperature, which is in degree centigrade, which is 34 here. So what we will do, we will add 273. So 34 plus 273. So that is equals to 307. So that is in Kelvin. But we have to find moles, and how to find moles? So as we know, if we know the mole mass in gram and we know the molar mass, so we have the formula moles equal mass in gram divided by molar mass. So mass in gram, that is given 29, and the molar mass, sorry, mass in gram is given 4 and the molar mass is 29. What's the answer? 4 divided by 29. So we'll get N, or moles. 4 divided by 29. The answer for 4 by 29. 0.14. So that's equal to 0.14. So we have this equation. P is unknown. We are finding V is a volume, which is 0.03. N is the number of the moles, which is 0.14. R is the general gas constant, which is 8.31. And T is the temperature, which is 307 Kelvin. Volume is multiplied, other side it will divide. So that's equal to 0.14 multiplied by 8.31 multiplied by 307 divided by 0.03. So we'll get P. What's the answer? So that's the final answer, which will be in Pascal, or you can say Newton per meter square. Is it clear, this example? So it's not a difficult formula, just you remember, memorize the formula and use the values to find the answer. Now we'll move on to this discussion of structure, the MCQs. First, it is January 2015. I want participation from everyone, even though if your answer is wrong, that's not an issue, because this is not a test, it's just to check your understanding of Unit 1. Today I will discuss MCQs and later I will discuss the whole papers. Okay, in this question, a solution contains 33 ppm of solute. The mass of a solute dissolved in 1 kilogram of this solution is, I will give a formula. So the concentration in ppm, ppm means parts per million. Concentration in ppm is equals to mass of solute, or moles of solute, divided by mass of solvent into 1 million. This is multiplied, it's not multiplied with numerator, it is multiplied with, sorry, it is not multiplied with denominator, This 10 exponent 6 is multiplied with numerator. So concentration in ppm is 33. So this value is given 33. Mass of solute we don't know. That's a question. Mass of a solvent is 1 kg. So that's in kg, but all the answers in gram. So this should be in gram. So 1 kilogram means 1000 grams are there into 10 power 6. So this will be 33 multiplied by 1000 divided by 1 million. What's the final answer? So 33 multiplied by 1000 divided by 1 million. So when you substitute, the C will be the right answer. Question 2. Avogadro's constant is equal to the number of Question 2. What could be the answer? Like Avogadro's constant is basically, look, the term Avogadro's constant means which contains 6 exponent 23 particles. It can be atoms, it can be molecule, it can, but 6 exponent 23. A gram, so gram of an element that contains 6 exponent 23 atom of that element. So because what happened if but that element, because that element can be monoatomic, element can be diatomic. Like example, if that element was oxygen, okay, so gram of oxygen which contains 6 exponent 23 atoms of oxygen, so this statement will not be true. Why it will not be true? Because the number of atoms present in oxygen, 1 mole of oxygen, because the ratio will be 1:2. So the number of the atom will not be equal to 6 exponent 23, it will be twice of that. So this statement is not explaining the Avogadro's constant correctly. Atom contained in 1 mole of any element, not any element, it should be a monoatomic element, the number of the atoms which are present in monoatomic elements. Because the monoatomic element means the atom have like one molecule will, or sorry, one atom will make up that molecule. Example, helium is there, neon is there. So it is a number of atoms which are present in 1 mole of monoatomic element, not any, because element can be exist as like oxygen element can exist as O2. So it will not have the same number as of atoms as Avogadro's number. Is it clear why statement C is correct? The particle, atom, ion, or molecule required to make 1 gram, that's totally wrong, because not 1 gram, 1 mole of a substance. It gram vary. Like example, for carbon, 12 gram of carbon will make 1 mole. For magnesium, which is 12 and 24, so 24 grams of magnesium will make 1 mole. So it vary, it is not constant. Question 3. Hydrocarbon contained by mass 82.7% carbon and 17.3% hydrogen. The molecular formula. But before working out the molecular formula, we should know the empirical formula. And how to get the empirical formula? First, divide by atomic mass. So 82 point, because the molecular formula is a multiple or the product of empirical formula. So 82.7 and this one is 17.3. So we'll divide by atomic mass. So this will be divided by 12. This is divided by 1. So 82.7 divided by 12. So that will make 6.89. 6.89 and this is 17.3. And then this will be 6.89 because we take a simplest ratio. So this one is 1, and then 17.3 divided by 6.89, that will be approximately 2.5. But whenever one of the ratio is 1.5, 2.5, 3.5, so what we will do? We'll multiply all of them by 2. So the empirical formula, like, because the simplest ratio, it should be in a whole number. So 1 is to 5, 1 is to 2.5, the simplest ratio in whole number, 2 and 5. So empirical formula is 2 and 5. Now, what is a molecular formula? Molecular formula can be same as empirical formula, or it can be a product, like multiple. But you can see this C2H5 is logically, it is not a correct molecular formula, because you have three kind of hydrocarbon. A hydrocarbon can be alkane. If it is an alkane, then the number of the hydrogen are twice plus 2 as compared to the number of carbon. So it should follow a general rule for alkane, which is CN H2N plus 2. If it was alkene, then number of the hydrogen should be twice. If it is alkyne, the number should be 2n minus 2. So this empirical formula and molecular formula cannot be same here. Why it cannot be same? Because this C2NH5 does not matches with any general formula of hydrocarbon alkane, alkene, or alkyne. So it means it cannot be C2H5. Then it should be a multiple of that. So what is a multiple of 2 and 5? Like multiply by any number. So which option? In option D, because if we multiply both of them by 2, it will be C2 and C4 and H10. So then after that, C4H10 is a multiple of empirical formula. So D is the right answer for this. For question 4, an ion with X minus contain 36 electrons. In which block of a periodic table would this X2 be found? So basically, if X is containing 36 electron, but what happened? But this is a chart. So neutral X will have, because it took electron, so neutral X will have 35 electron. And we only, in a periodic table, we have elements, we have the structure or we have the position of element, but not about the ions. Like for elements, we say D block element, S block element, P block element. So when I write the electronic configuration for this, I have to arrange 35 electrons. So it is 1s2, 2s2, 2p6, 3s2, 3p6. This is one way of writing the all the electronic configuration. Or there's also another way. What I can do, I can work out, because I know the if number of electrons are 35, number of protons should also be 35 for a neutral atom. So I will check the periodic table which element is having atomic number 35. Instead of writing that whole, so which element is having atomic number 35? So you can see bromine is having atomic number 35. And what is the block of bromine? It is known as a p block element. Why we call p block element? Because this whole region is a p block. The first two, group 1 and 2, are S block, group 3, 4, 5, 6, 7, and 8 are P block. In between them, D block, and the lower are F block elements. So I can write electronic configuration, but because it will take time to complete that electronic configuration, so I can use a short method in which I will work out the, using atomic number, I will work out the position of that element. So because it belongs to P, so that's why. B is the right answer. Then consider the following data. This is related. You will study about enthalpy change, but that this part of enthalpy change is in unit 2, not in unit 1. In the question, which of the following result is the most polarizing cation? Because what happened, the practical lattice energy and the theoretical lattice energies have difference. Why they have difference? Because a distortion is there, a negative ion distortion occur. So which negative ion will have greater distortion? So positive ion should be smaller. When positive ion is smaller, it can attract the electron easily, and negative ion should be larger. That's why B is the right answer. In this question, this is related to moles. Calcium carbonate react with dilute nitric acid as follows. 0.05 moles of calcium carbonate were added to a solution of 0.08 moles of nitric acid. Which of the following statement is true? So because the ratio is 1 is to 2, so from this we can identify, because if calcium carbonate is 0.05, then nitric acid should be 0.1. But it is not 0.1, it is 0.08. So nitric acid is a limiting reagent. 0.05 moles of carbon dioxide produce. So when you check, because you always check from a limiting reagent, so that is wrong, because nitric acid and carbon dioxide, the ratio is 2 is to 1. And how many moles of nitric acid we have? 0.08. So how many moles of carbon dioxide will be there? X. When I cross multiply, I will get 0.04. Sorry, this was 0.08. So cross multiply 0.08 divided by 2. So I'll get 0.04. So this statement is not correct. Then we'll check the second statement. 0.08 moles of calcium nitrate are produced. It is not possible, because the ratio between nitric acid and calcium nitrate is 2 is to 1. So if the ratio is 2 is to 1, if we have 0.08 moles, then this will be X, cross multiply. Again, we'll not get 0.8, we'll get half of that. So that statement is also wrong. Calcium carbonate is in excess. Already we worked out that 1 is to 2 is the ratio. If 0.05 is there, then this will be 0.1. But we don't have 0.1, we have 0.08. So which statement is true? Statement C is true. But in this case, nitric acid is, so that's totally wrong, because nitric acid is a limiting reagent. Even this value, I can work out this value, but because the statement, only statement in which the calcium carbonate is in excess, and that's a true statement, that's why I did not bother about calculating the mass which is in excess. Is it clear, this part, this question? In which of the following pair does each gas occupy the same volume? Basically, when the moles are same, and they mention all volumes are measured at the same temperature and pressure, so temperature and pressure will not affect the moles. So we'll use the formula volume is equals to, or we can find the moles. So moles is equals to volume in dm cube divided by 24. This is one way, but we don't have the volume, we have the mass of each gas. So you can see, when moles multiply by 24, we'll get the volume. So if we get the same moles, it means they will have the same volume as well. So we will find the moles for each One by one. For option A, if I find the moles of hydrogen, mass in gram is 2 and hydrogen is H2. So it will be 2 divided by 2, 1 mole of hydrogen. But what about nitrogen? Mass is 14, but nitrogen is existing as N2. So 14 multiplied by 2, 28. So what I will get? I'll get half. So this is not right. 32 gram of methane and 88 grams of carbon dioxide. Methane is CH4. So 32 divided by carbon is 12 plus oxygen, hydrogen is 4. So this is 16. So I will get 2 moles of methane and carbon dioxide mass is 88. Carbon is 12 plus oxygen 16 multiplied by 2. 32 plus 12 make 44. So 88 divided by 44, I'll get the 2 moles. So if the moles of the gases are same, it means they will have the same or occupy the same volume at same temperature and pressure. That's a condition. Otherwise, if the temperature and pressure are not same, they will have different volumes. Then consider this reaction. What is the maximum? What is the maximum volume in dm cube of nitrogen dioxide that could be obtained in a reaction when 1 dm cube of nitrogen monoxide mixed with 2 dm cube of oxygen? So first thing for these type of question, when both reactants are given, always find the limiting reagent. So 2:1 is the ratio. If 1 mole of nitrogen monoxide or 1 dm cube of nitrogen monoxide x dm cube of oxygen is there, so when you work out this x, it means 0.5. So 0.5 dm cube of oxygen. So if 0.5 dm cube of oxygen is needed, but you have 2 dm cube of oxygen, so oxygen is excess and nitrogen monoxide is a limiting. And the ratio between nitrogen monoxide and nitrogen dioxide is a 1:1 because 2:2 or 1:1. So if I have 1 dm cube of nitrogen monoxide, I will have 1 dm cube of nitrogen dioxide. So that is why A will be the right answer. So whenever both reactants are given, you have to find the limiting reagent. Is it clear, this question? I'll share another link because this session will end less than a minute. Any question till now?